So now we want to start graphing piecewise functions. So I just drew in the coordinate grid right in the middle. We're going to make right in our scale. We're just going to do a scale of 1. So this will be 5 and -5. And we can also do 5 and -5 down here. So there are probably different ways to do graph these. The way that I always graph this is I always figure out my endpoints first. So I can see my endpoint occurs when x is 0, or one of my ends. So I'm going to put in 0, and I'm going to evaluate 0 at this point. So -4 times 0 is 0. And then I'm going to also evaluate my second one, even though it's not included. I still want to see what it would be at that value, so I'm going to put in 0, and it tells me that for any input, my output is just 4. Okay, I also think, especially as you first get started with this, or equal to tells us closed circle. Straight inequality tells us open circle. So I'm going to graph the point 0, 0 as a closed circle. And then to the left of 0, so when x is less than or equal to 0, right, that's all these inputs. I need this to be a line with a y-intercept of 0, so that makes sense, but a slope of -4. So a slope of -4, right, that our slope of -4, that corresponds to -4 over 1, which would mean down 1 and right 1. So if I went from here and went down 4 and right 1, that would work to find the line, but notice that these are not the x values I need it to be. I need to look at the part of the graph to the left. So I need to remember that I could also write my slope as 4 over -1, which means I'm going up 4 and left 1. So if I go up 4 and left 1, that gives me a second point, and this branch would be the line over here. And then for my second branch, I want to graph the point 0, 4, but I need an open circle there. And then I need the horizontal line y equals 4. So I'm just going to graph a horizontal line like this. Okay, so my piecewise function was defined with 2 pieces. I can see 2 distinct pieces on my graph. I also notice that this is still a function, right? It still passes the vertical line test. For every input, we have 1 output. Okay, for number 11, same. I'm going to put my grid right in the middle. So I'm going to find my endpoint values. So this will be 2, 4 minus 2 is 2, and open circle. And this one will be 2, comma 5, and this would be a closed circle. So looking at this, I want to graph the point 2, 2 with an open circle, and I want to graph the point 2, 5, but that's not going to show us an awful lot of our graph, right? So let's move everything a little bit. Let's move so that our origin kind of looks like this. So this will be 1, 2, 3, 4, 5, 6, 7, 8. This will be -2, -2, and +8. So again, we're going to graph 2, 2 with an open circle. And we're going to graph 2, 5 with a closed circle. And on the left, I want to have a slope of -1 and a y-intercept of 4. So I'm going to go to my y-intercept of 4, my slope of -1. So that's my first piece. And then on my second piece, I know that it has the 0.25, and I can also see that I want a slope of 1. So I'm going to go rise 1, run 1, and my graph would look like that. And if I continued that graph, it would have a y-intercept of 3. Okay, but I only want this piece of the graph when x is greater than or equal to 2. Okay, our next one, we have 3 pieces, okay, but the method is the same. What I do is I find the endpoints of the first piece, so -2, -2 times 2 is 4, and that's going to be open. This next part is a little different because I actually have 2 endpoints. I have -2, 2, which is going to be closed, and I have 2, 2, which is going to be open. And at the bottom, I have 2, -4, which is going to be closed. So looking at this, this has a y-intercept of 0, this has a y-intercept of 2, this has a y-intercept of 0. So I think that if we put our grid in the middle, we'll be okay. So our first point, -2, 4, has an open circle. And I have a slope of 2, okay, but I'm coming to this. I got confused. It didn't make sense because I have an arithmetic mistake. I'm sorry, this should be -2, -4, and that makes more sense. Sorry about that. So -2, -4 would be down here. So this isn't a very good picture, but it would have a slope of 2 on this branch. Then I'm going to graph -2, 2 with a closed circle, and 2, 2 with an open circle, and then 2, -4 with another closed circle. And on that side I want a slope of -2x, so it'll look something like that. Okay, so a couple of things. Notice this still passes the vertical line test. There's one point here and an open circle here, so it doesn't fail the vertical line test. This is the only point on that vertical line. Same here. Okay, and let's everyone take a second, pause the video, and find your endpoints and if they're open or closed for number 13. Let me double check and make sure I didn't make any mistakes. So at my endpoint -1, my y would be -1. It's included, so it's closed. At -1, it would be 0, not included, so open. At 2, it would be 0, not included, so open. 2, 1, included, so closed. So let's draw a quick sketch. Okay, so at -1, I'm down at -1. And to the left of -1, I'm always at -1. So I have a horizontal line like this. At -1, 0, I have an open circle. And at 2, 0, I have an open circle. and I have a horizontal line like this. And finally, when x is greater than 2, at 2, 1, I have a closed circle, and I have the horizontal line 1. Okay, so I can see 1, 2, 3 pieces here, and I broke into 1, 2, 3 pieces here. Again, please stop the video here and look at the third segment.